Hi everyone, Krishna this side and I welcome you all to this channel. So in this particular video, we will be covering the lead code problem delete and earn. And this is similar to the recent problem that we just solved, that is house robber. Okay, but just small modifications are what really needed here. And once you're able to get these problems technique solution technique, you guys can easily solve similar kind of problems. Okay, and yeah, let's just quickly go through this problem statement. I'll explain you what it is. You guys can pause the screen and go through it. So we just have given an array, and in the array we need to pick points, and once we pick the particular point, we need to just skip the addition values of that particular value. Okay, so if I choose 4, so for what are the addition element to the 4, that is 3 and 5, right? So if 3 or 5 that is available in the array, we just need to skip them. So it is kind of similar to the house robber, right? So only constraint was that there the houses are in the adjacent, but these elements are not in a sorted order. Okay, so we need to consider them in a such a way that this will kind of look like similar to the house robber one. Okay, so yeah, of course we need sorting to this array, but there is another thing. Okay, so there is a possibility that the element either be there or not be there, but we need to think in a such a way that the element is actually there, so that we can process that, and we for the next coming element we can use the previous elements values for the computation. Okay, and another thing is like the values are again they might may be repeated. Okay, so if values are repeated, we just need to consider all of them. So 3 here repeated 3 times. Okay, so this gives us 9. So if we consider 3, we cannot choose 2 or 4, right? So if we choose 3, so the answer is 9, correct? So even if we choose 2, we cannot choose 3, right? So here it gives 4, and once we skip 3, we can choose 4 also, right? So 4 plus 4, that is 8. So what is the maximum answer sum that we got? 9, right? So that's what we need to return. So yes, we have to consider these repeated values again in our solution as well, right? So let me write the code, and through that I'll explain you like how we can solve it. Okay, and with the example also I'll explain you like how I am writing the code, and what should be our approach as well, right? So see, the way I look into this particular problem is like I need to get the maximum number from this array, so that I can create a DP array, and whatever the values that I compute for each index, the maximum answer is something what I'll be keep on adding in those indices, right? So that's what we did in the house robber problem as well, right? So definitely I need the maximum value from this array, and how I can get it, like let's get the maximum value as well. Int num from the nums, max equals math dot max num comma max. Okay, so we got the maximum value, and now I can create a DP array of this max size, max plus 1. And why I'm doing all these things, I'll explain you. And once we write this solution, you guys will get the idea like, okay, that's how we are trying to solve this problem, right? So these things you guys will get to know. Now once we create a DP array, I'll do is, see, we can actually maintain the hash map, we can sort this array and all, but there is simple approach that we can do here. Okay, so instead of sorting or maintaining a hash map and keep on adding these values for those indices, what we can do is simply we can add them in this particular DP array. Okay, what I'm trying to say is like int num from the nums. What I'll do is DP of num, I'll simply add that value. What I'm trying to do here, I'll explain you. Okay, we have 2, 3, 4, 2, 5, 7, 6, 7. Okay, this is the nums array we have. Okay, so this is the nums array. Now I have created a DP array. DP array is having length of 7, right? So if it has the length of 7, let me write the indices over here: 0, 1, 2, 3, 4, 5, 6, 7. That's the length we have, right? Max plus 1. So max is 7 from this nums array, so 7. So that this is the length of the DP array, and the indices is something what I have mentioned. Now what I have done here, nums from the for the each DP of nums. So here currently num is 2, right? So DP of 2, I am just adding that 2. So currently DP of 2 is 2, right? Now what is the next element? 3. So DP of 3, what I am considering? So here I just need to keep on adding those values. Okay, currently dp of 3 is 3, then 4 is there, right, in terms of so dp of 4, what it will be, 4. Okay, that's how I am filling the values, right? So in the dp array, so these are the dp arrays values that I am trying to keep on filling through this particular one. So dp of nums, now the num is 2, again dp of 2, it has already 2, right? So I am just adding with those, that particular value, this current value as well. So now it gets separated with the 4. Okay, and then it is 5, right? So dp of 5 is going to be 5, and dp of 6 is going to be 6, and dp of 7 is going to be 7. And if you, even if I do have 3 and 2 again, okay, so dp of 3 is going to be updated with 3 plus 3, that is 6. And dp of again 2 we have, right? So dp of 2 is going to updated with 4 plus 2, that is going to be 6. So this is how we are just maintaining the dp array, and remaining values will be 0, because by default, if the array, there is no array element in the values that we said, by default those values will be 0, right? So this is how our dp array looks like right now. And if I now go through this array, right, so this is kind of in a sorted order, and definitely the values are actually placed at correct indices, right? So I don't need to bother like how many times 2 has appeared, right? So at second index, the value, how as many 2's we have, that sum is already filled with this dp array. Now this is like exactly now the kind of this problem transformation into the house robber. Now we just need to pick the any additional elements in a such a way that sorry, any elements in a such a way that no two houses, I'm just considering this into the house robber problem. I mean, this particular array is kind of same to the house robber problem, right? So if I choose 6, I cannot pick this one or this one, right? So if I choose this, I need to either pick max of this one or this plus this, right? Because I just need to consider I mean, just need to omit the argent values, right? So kind of similar to the TP array. Now we can just traverse from this array, I less than 2, I less than max, sorry, I plus plus. Now what we can do is for the second one, so this will be like equals to, okay, because we are traversing till that one. So from the second array, dp of I, same formula here it gets applied, but instead of nums of I, now we just updated dp array itself. So dp of I minus 1, either the max value between that, or dp of I minus 2 plus dp of current value. There we used to consider here nums of I, but now since the dp array itself we transferred into the house robber problem, so we can directly consider that itself. Okay, so in the dp of I, we can simply just get the values, and at the end return the dp of max. Okay, because at the last element we will be getting the maximum value. Okay, so that's how we can transform this problem into this I mean